Hi guys, welcome to my Georgetown domains and discussions topics about ARIMA models. So my dataset is mainly from finance.yahoo and Google Trends. My topic is about the web conferencing industrials, and I set this WebEx by Cisco as my target company to discover its price trend. So in the formal exploratory data analysis part, the portfolio digged deeply for the components of Cisco's stock price trend by changing the stock time series from unstationary to stationary. And for this part, this portfolio mainly utilizes ARIMA models in R to choose the most optimal parameters for the model. So here is the stock price trend for the Cisco company. It ranged from the year of 1990 to the year of 2022. So the first step I did is to compare the original ACF plot and the ACF plot of the log transformed one before difference in process. And I found that for both ACF plots, they all have very high correlations, which means more processes are needed to make it more stationary. And then I used the ADF test to validate it, and I found that for the original one, the p-value is equals to approximately 0.05, and for the log transform one, it would get a result of 0.03. So yeah, it indicates the process Cisco time series are not statistically stationary. So I then did the first difference in process for the log transformed, and I found that it actually works for ACF. It shows that all legs are inside the confidence bands, and we can then set the d equals to 1 and set p equals to 0. So for PACF plot, there is no high correlation after leg 6. So at that time, I just set q equals to 6, but for now, I think maybe q equals to 0 might also be a good choice. So for the ADF test for this one, it shows the p-value as 0.01, which indicates the process Cisco time series are statistically stationary. It also means the success for the stationary process. I also have a model diagnostic for ARIMA 016. The standardized residual plot shows the mean value of the residual is around 0. So, and also as years goes up, it shows the variance become less, and the pattern becomes more stable. So for the normal QQ plot of standard deviation residuals, it shows approximately a linear relationship. And also we found that the p-values are significant, which means that the residuals are independent, and this is what we actually want to for the model to be correct. And also I found auto ARIMA. However, it's very interesting that the auto ARIMA suggests using like the second difference in, or just not using any difference in process, which neither fit the information of ACF and PACF plot previously provided. So I then used the ARIMA 016 to forecast models. It includes a stock price prediction for Cisco company in a very specific period. And I verified this forecasted model with a screenshot from the Yahoo Finance. And yeah, it actually confirms the trend and range of the ARIMA forecasting model. And also then I compared the model with the benchmark methods. Since RMSE is a very good measure of how accurately the model predicts the response, we can then sieve out the mean methods and keep the naive and random walk method as the very low RMSE value. And to compare these two, I then compare their value of MAPE, since higher number of MAPE are bad. So because MAPE is measure of error, so I then choose the naive methods as a good fit. Thank you.